Hello, what's up? Today I want to talk about how to add two numbers in a linked list. It's a very interesting interview question and it might come up during our interviews. So the question goes like this. You are given two non-empty linked lists representing two non-negative integers. The digits inside our linked list are stored in reverse order and each of their nodes contain a single digit. So it cannot be any number bigger than 10 or bigger or equals to 10. Bigger or equals to 10. Add the two numbers and return it as a linked list. For example, 342 reverse 243, 465 reverse 564. Then we add them together, get 708 as our result. So we can use this block of code to come up with the same two linked lists as to take in as our input. And the first time I saw this question, I come up with this very naive and very bad solution in terms of code efficiency, time complexity, and memory usage. But yeah, but I just thought I should explain it to you first, so we can discuss how to improve upon it and actually squeeze down the code and make it a better function. All right. So first I just declare a new result linked list and passing a new node as head. So as you can see, I put the value here, just a string value of head. And then I write a recursive function passing the current node of list 1 and list 2 and passing the result node and a reminder that's going to down the carry. So I will initialize them with our L1, L2 and result head for sure. Then I just list down all the base case I can think of when the current node is null and I check the carry and so the reminder. So reminder is referring to when 9 plus 9, for example, equals to 18, I want to return 1 as the reminder, and so and to be added during next iteration. So when it's bigger than 0, push it and return, or else just return. When one of the node is empty, do the update accordingly. This block of code as well. And when the two node is both not empty, and we can just do the update accordingly. As you can see, these codes are pretty redundant, but they are a little bit different, so I just keep them there. But there is actually a lot of room to make improvements after I brought through the other solutions in LeetCode. So let me just write it down for you so we can discuss them. But first, I think we can run our solution here. Make sure it's a valid solution. So node add two numbers in linked list. So 708, just as expected. Okay, function add two numbers, takes in L1, L2. So the first step for better solution is also use this block of code. We need a result head, but then we also need a result node. So we, instead of putting our result node, current node, for results linked list inside a recursive function, we put them outside and just make it equals to result head in the end first. Then we need a carry. So this time I will call our reminder carry because that's the wrong term to describe it and make it equals to 0 first. Then we just do a while loop and say if L1, meaning the node, is if it's true C value, or L2 is a true C value, or our carry is also a true C value. So if it's 0, it's falsy. If it's bigger than 0, of course, it's going to be a true C value. So immediately we have put in a lot of the condition in our base case and integrate them into one condition. It's a very good solution I found on another user's submission. code. So anyways, let's move on. Then inside our while loop, we first need to check what's the value for our list one. So if list one is a true C value, then we can just make our value one equals to L1 value property, or otherwise we return 0, and we can do the same thing for value 2 as well. Alright, so next, then we can say constant value, meaning the ultimate value should be equals to v1 plus v2 plus our carry. Okay, then we can start updating the next property of our result node. So our result node should be equals to result node dot next should be equals to new is, and let's pass in the value here. Divide by 10 and get a reminder. So in case you are confused about this part, we have discussed it, the same thing in Redux sort. Actually, when we want to get the first digit of a number, for example 999, we can first divide by 10, so it will become 999.9, and then we just need to get a reminder here. So reminder operator is this. So when we want to get the first digit, we just need to do this. So we get the first digit and push it inside our result linked list, and then we can update our result node and make it equals to our result node dot next. All right. After this is done, we can then update our carry. So carry equals to our v, then check whether it's bigger or equals to 10, meaning is it still a single digit value? If not, we push 1 inside, because in addition, the best carry value we can get is 1, or otherwise it will just be 0. Alright, after we update our carry, we can then update our list 1 node and list 2 node. So in this case, L1 should be equals to L1, and if it's true C value, we just return L1.next, and we can do the same thing for L2. So by the end of this, I think our result linked list will be generated. Then we can just return result head dot next. Okay, let's rerun our function. So you can see 708. So basically, this is a much better solution, and the key to it is actually understand the question, right? What happens, how we can add in the values in a integrate way, and not to think about the case, integrate the algorithm, considering all the base case, and make like sort of a summarized version of how we can get our value, how we can get our single digits, and how we can update our carry value and check it inside our algorithm. So I think that's a very clean solution right here, and it's something to think about for myself. So I hope this is helpful. Thank you for watching, and have a nice day.